Welcome to the Science Bros. I'm Oscar, and here with me today in voice we have Alicia, Sarani, and Sam. Tonight we're going to be guiding you through the process known as recrystallization. I know it sounds complicated, but with the help of my compadres, we're going to guide you through it with some neato visuals to make sure that you at home can follow along. But before we start, please do make sure that your arms and legs are kept safely inside the vehicle at all times, your seatbelt remains fastened, and your helmet stays buckled up, buckaroo, because this is going to be one wild ride.
The process of recrystallization starts by dissolving the impure substance called a solute into a solvent. A solvent is any liquid which can dissolve a solid substance. For example, impure benzoic acid crystals can be dissolved in water. This example will be used throughout the rest of the video. Heating is required in order to properly dissolve and prevent crystals from forming before the impurities can be removed. As heat increases, the amount of solute allowed to dissolve in the solvent also increases. Depending on the solute, some impurities may have insoluble solids which cannot be dissolved. These are later removed in the next stage. Once the solute is properly dissolved into the solvent, the removal of impurities by means of purification can occur.
During the purification aspect of this experiment, approximately 1 level teaspoon of decolorizing charcoal is to be added to the solution and then returned to the heat. This is done because the charcoal will preferentially bind to and take up impurities dissolved in solution. The filtration step must be conducted with the apparatus still on the heat source as to negate the effects of the colder external environment on the solution, ensuring it does not recrystallize during filtration. In this case, a purified sample of benzoic acid, and in the filter paper above lie all the impurities now binded to the charcoal. This means that when the solution is filtered through gravity filtration depicted here, all that remains in the clean conical flask below the filtration funnel is a purified and transparent sample of the solution awaiting recrystallization in the next stage of this process.
After purifying the impure substance, in this case benzoic acid, set aside the hot flask from the heat source. Let the flask cool down to room temperature before putting it in an ice bath. If you put the flask in an ice bath straight after you take it out of the heat source, it's going to crack the glass. After the flask has cooled down to room temperature, now you can finally place it in the ice bath. Let this sit in the ice bath for a while, and as you wait, you will see the crystals starting to form inside the flask. The flask should cool down to about 4 degrees before you take it out. When the crystals have formed, take the flask out of the ice bath. Now you need to separate the liquid waste and the crystals out of your solution. To do this, you have to filter out the liquid from your crystals. This can be done through the use of a Buchner funnel and a Buchner filter. Connect the Buchner funnel to the Buchner filter and connect the Buchner filter to a filter hose. Now gently swirl the solution and pour little by little into the vacuum. The vacuum sucks up all the liquid and leaves the solid crystals on the filter paper. Do this until all of the solution is emptied, and if there is some content still left in the container, rinse it with cold or distilled water and pour it into the vacuum. After the vacuuming has finished, leave the filter paper to dry in room temperature.
Now that we know how this process is undertaken, we can start to talk about how and why it's used in everyday life. Because of its ability to perfectly purify a compound, it's widely used by scientists and the like to obtain a substance to perform an X-ray analysis on. This is the process used to discover the 3D shape of a molecule. Because of the purity needed for this process though, unlike our example, their samples are left to cool over weeks or even months to ensure the structure has formed correctly. The process of recrystallization is even used in the production of some food, mainly sweets such as rock candy. This is done with a supersaturated solution of water and sugar, which is then heated and allowed to cool, forming the precipitate that we then extract and consume. But the main use case for recrystallization is for pharmaceuticals, in which common drugs such as aspirin are produced.
Thanks for watching. We hope you enjoyed learning about recrystallization. Tune in next time for more fun science with the Science Bros.